Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together.
If you've watched some of my earlier videos, you might have known that I've done transformations before, but this is going to be about similarity transformations, meaning that the ending shape is not going to be congruent to the starting shape. So this is going to be a composition of one or more rigid movements and a dilation. Okay, so we're going to see a rigid transformation composed with a dilation. Okay. They are going to be similar in shape, not exact. Kind of like thinking that all maps kind of show the same thing, but they might be different sizes based off what you zoom in. Okay. So that's going to be very important. Now, a fun fact: all circles are similar to each other. Just a fun fact. So anytime you do a circle, it's going to be a similarity transformation if you go from a small circle to a big circle. Okay, so what you might see is a right triangle, and we might slide it to the side and get a second right triangle, and then we might do a dilation and make it a bigger right triangle. We are going to use this to mean similar. Wow, only one L here. Okay, remember this meant congruent. And if you're typing it on the keyboard, you usually find this symbol if you look up by the numbers in the top left corner by number 1. The button to the left of it usually has this symbol. It's kind of hard to get this symbol on the computer. It can be done if you have special programs or you know where the math little functions are. Okay, so these were congruent, but this was similar. So triangle XYZ is going to have x at 3, 5, y at negative 1, 4, and z at 1, 7. We are going to do D2 composed with T for triangle X, Y, Z. So if you remember compositions, you start at the end and you work backwards. So we're starting with triangle X, Y, Z. All right, let's get it put on there, right? One, two, three, 1, 2, 3, 4, 5. There's X. Negative 1, 1, 2, 3, 4. There's Y. And 1. There's Z. I am having an issue with drawing straight lines today. Okay, so we've drawn our XY, so now we need to translate it using vectors 1, negative 2. Okay, so write 1, down 2. Write 1, down 2. Write 1, down 2. So that's a congruence transformation because our segments stayed the same size and our angles are going to stay the same. Our angles are always going to stay the same. Now we have to do the dilation. Dilation scale factor 2 around the origin. So if you've watched my scale factor video or my dilation video, you know that since these are coordinates, we can use the slope. So since up 2 is going to become up 4. 1, 2, 3, 4, 5, and 2 will become 10 and 4. So there's 4, 5, 2, 1, 2, 3, 4, 5. Whoa. And we've got 1, 2, 3, 4, 1, 2, 3. So 1, 2, 3, 4, 1, 2, 3. And we can see that this triangle has greatly enlarged. And if you want, you can go ahead and you can make sure that, we've doubled these out correctly by drawing a straight line from the origin through X and X, X with the mark and X with 2 tilde marks, and making sure that the origin to the purple is this double the origin to the green. But I just used the slope, that way I wouldn't have to actually draw all of those lines. If we didn't want to do that, do we know how to do this mathematically? Okay, so we're going to write down our X, Y, and Z points. 3, 5 was X. Y was negative 1, 4. And Z was 1, 7. Okay. First thing we needed to do was translate it 1, negative 2, which means plus 1 minus 2, plus 1 minus 2, plus 1 minus 2. So that gives us X at 4, 3, Y at 0, 2, Z at 2, 5. Then we needed to dilate, and because it was around the origin, we can just use our scale factor to our coordinates. So 8, 6, 0, 4, 4, 10. And again, triangle XYZ is congruent to triangle XYZ, and they are similar to triangle. Similar means that they have the same angles, but the side lengths do not match. Okay, so this is just a combination of some of my previous videos, because I've done some similarity work, I've done some congruent transformations. This is kind of just putting it all together. So if you had the other ones pretty solid, but you needed just a general refresher on them, this video kind of takes care of that. But again, you can draw them one at a time. You can go ahead, if it's on coordinates, it's really nice because we can use algebra if we're not geometrically minded. So either way, you can go ahead and take that over, but it's just a composition of multiple things. So remember, this open circle means chain reaction, and you'll eventually be doing that in algebra.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.